Good morning, everyone. Am I audible? Am I audible? Benison, good morning. Yes, I'm audible, right? Okay. 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 Um, okay, so today we will start one new topic, okay? So let me share my screen. Okay, so we have discussed about the treatments. Okay, so what treatments are needed to give to the sewage? Okay, before disposal. So now, and after the treatment is done, so now it's time for the what disposal of the sewage, isn't it? So now we will discuss about the in this chapter or in this new topic we will study about the source of disposal of sewage and also the various methods of disposal of sewage. Okay, so there are certain methods like how you will dispose the sewage, where will you dispose the sewage, and what are the sources of disposal of sewage. Okay, so there are certain things so that we will discuss in this chapter. So now the study of this, the sources of disposal, it is very much important. Because why? Because the amount of treatment, okay, that is required to be given to a sewage, okay, it depends on what? It depends on the source of disposal. Okay, it depends upon the source of disposal and also its quality and capacity, how it will tolerate the impurities that is present in the sewage effluents. Okay, so without getting polluted or become less useful. So that is why the study of the sources of disposal, it is very much important. So now there are two methods. Okay, there are two methods how will you dispose the sewage effluents. Okay, so number one is your dilution method. Dilution method, also known as your disposal in water. So the sewage, it is also disposed in water, and so that is known as the method is known as your dilution method. Okay, and number two is your effluent irrigation or broad irrigation, or also known as your sewage farming. That is this three same name. So you may name it as sewage farming also, you may name it as your broad irrigation also, and also your effluent irrigation, same thing. Okay, so basically this means that disposal on land. So one is your disposal in water and the other one is your disposal on land. Okay, so now first we will discuss about the disposal by dilution, that is disposal in water. Okay, so like from the name itself, you got an idea like disposal by dilution. What it is? It is the process by which or by whereby the treated sewage. You have treated the sewage by all these processes we have learned. So after the treatment, you will like the treated sewage or the effluent from the sewage treatment plant. It is discharged into a river stream. Okay, it is discharged into a river stream, or maybe it may be a large water body, or you can say like it may be a large lake or sea. Okay, so like disposal by dilution is it you dispose the treated sewage to a river stream or a large water body such as a lake or a sea. Okay, so now the discharged sewage that you have disposed of in the river, in due course of time, what it will do? So in due course of time, that discharged sewage, it will be purified by itself. Okay, it will get purified by itself, and that is known as what? That is known as self purification process of natural waters. So this is a term. Okay, the river, it has a like it has one speciality. Okay, the river or the water body, it has a speciality that it purifies. Okay, it has a self purification process, it has a self purification quality. Okay, so the discharged sewage which you have disposed of on the rivers or on the like in the sea or lake, so that will like in due course of time, as time passes, that will get purified by itself. Okay, and that is known as your self purification process of natural water. Okay, and now the degree and the amount of treatment which should be like given to the raw sewage before disposing it all into the river stream. Okay, it will definitely depend on what? It will depend upon the quality of the raw sewage, but also at the same time, it will also depend upon the self purification capacity of the river stream. Okay, so this term self purification capacity of the river stream, if like one more question comes, what do you mean by self purification capacity of the river stream? So if you write this part, okay, this part also you have to make by yourself, then one more question you can write it down. Okay, like that it this what is this, what do you mean by self purification capacity of the river stream? So you can write, you have understood, so you can write from here. Okay, so now there are certain conditions for disposal by dilution. Okay, you just cannot dispose it of like you want. Okay, those there are some certain conditions which are, you know, which you need to follow for disposal by dilution. Okay, so number one is your what? When the sewage it is comparatively fresh. Okay, when the sewage it is comparatively fresh, like only it's 4 to 5 hour old. Okay, it's only 4 to 5 hour old, so that is your fresh sewage. And also it is free from the sewage, it should be free from floating and settleable solids, or and those are already removed by your primary treatment. Okay, so that is one condition. Number two is your like when the diluting water, or you can say the source of disposal like the lake or sea or river. Okay, so when this source of disposal it has a very high dissolved oxygen content. Okay, this DO content we have already learned in the treatment chapter, isn't it? So when the diluting water or the river or the sea or lake, it has a very high dissolved oxygen content. So it is also one of the condition. So number three condition is what? Where the diluting waters are not used for the purpose of navigation or water supply for at least some reasonable distance on the downstream from the point of sewage disposal. So navigation everyone knows, yes, like the boats and the like the ships and all. So like that diluting water, it should not be used for the purpose of what? Navigation or water supply. Okay, it's not like that the whole thing, the whole water, diluting water, it should not be used, or the whole sea or lake, it should not be used for navigation or water supply. But it is said that it is for only like at least some reasonable distance on the downstream from the point of sewage disposal. So where you have disposed the sewage, from there, for at least some reasonable distance on the downstream, the diluting water, it should not be used for the purpose of navigation and water supply. Okay, so number 4 is that where the flow currents of the diluting waters are favorable, causing no deposition, nuisance, or destruction of aquatic life. It means that swift forward currents are helpful. Just a minute. Okay. Like when the flow currents of the diluting waters, they are favorable, okay, causing no deposition or nuisance or destruction of aquatic life. So this is an important point. Like you cannot destroy the aquatic life of the river or sea, or like this river. Okay, so what happens? The flow currents of the diluting rivers, those are favorable, causing no deposition or nuisance or destruction of aquatic life. Okay, so like on the these swift currents, the some forward currents are there in the river, so those are helpful. Okay, so they can easily carry away the sewage, and like on the other hand, some back currents are also there, and they cause what? Sedimentation, resulting to your sludge process. Okay, so next is your, when the outfall sewer of the city or a treatment plant is situated near some natural waters having large volumes. Okay, so like when the outfall sewer, that means the sewer from where the like the sewage will come out. Okay, so that is your outfall sewer. So when the outfall sewer of the city or the treatment plant, it is situated near some natural water bodies, okay, like sea or river or lake, okay, and having large volumes. So this is one of the conditions. So these conditions are what you have to consider for your disposing the sewage, okay, by dilution method. So again, now there are some certain standards of dilution for discharge of wastewater into river. Okay, so there are certain dilution factor also, you can say. So like you see here, this ratio of the quantity of the diluting water to that of the sewage is known as what? Dilution factor. That means the ratio of the quantity of the diluting water, okay, to how much of sewage you are disposing of. Okay, so that ratio is known as your dilution factor, and depending upon this factor, the Royal Commission report on sewage disposal. There is a certain committee, okay, the Royal Commission report on sewage disposal has laid down the following standards of and degrees of treatment required. So this table you are seeing, this table, so this is like there are certain dilution factor, okay, some numbers are there, and regarding that numbers you can say how much of treatment is required to be given to that sewage. Okay, so you see, if the dilution factor it is like above 500, so what does it mean? It means that no treatment is required. Okay, no treatment is required if the dilution factor it is above 500. So the raw sewage, whatever raw sewage is formed, so that can be directly discharged into the river or sea or lake, okay, directly discharged into the volume of dilution water. So now if the dilution factor is between 300 to 500, so what does that mean? So this means that the primary treatment such as plain sedimentation should be given to sewage, and the effluents it should not contain suspended solids more than 150 ppm. Okay, so here plain sedimentation, plain sedimentation treatment should be given to the sewage, and the effluents it should not contain any suspended solids and which are more than 150 ppm. So next is your like between 150 to 300, if the dilution factor is between 150 to 300. So what does that mean? It means that the treatments such as your sedimentation, screening, and essentially chemical precipitation are required. The sewage effluent should not contain suspended solids more than 60 ppm. Okay, so here your sedimentation, screening, and the chemical precipitation, okay, like that we have done, no, the coagulants and all. So the chemical precipitation, those are required if the dilution factor is between 150 to 300. And here the sewage effluent it should not contain any suspended solids that is more than 60 ppm. Okay, and the last one is when the dilution factor it is less than 150. So when the dilution factor is less than 150, so that means that the complete thorough treatment which should be given to the sewage, and the sewage effluent it should not contain suspended solids more than what, 30 ppm, and its 5-day BOD at 18.3 degrees Celsius should not exceed 20 ppm. So we have learned about the BOD test, right? So if you do the BOD test at 18.3 degrees Celsius, so that value it should not exceed your 20 ppm, and here the complete treatment should be given to the sewage. Okay, so this is a table like the standards of dilution based on what, Royal Commission report. Okay, so next is your dilution in rivers and self-purification of natural strips. So here we will learn the same thing, but we will discuss it nicely. So here it's written here, you see, when sewage is discharged into a natural body of water, the receiving water gets polluted due to waste products present in sewage effluents. Okay, so but the conditions do not remain so forever, because the natural forces of purification, such as dilution, sedimentation, oxidation, reduction in sunlight, etc., it will go on acting upon the pollution elements. Okay, so you see here, so when the sewage it is discharged into a natural body or a river or a lake or a sea, so what will happen? The receiving water, so the river, okay, the river or the lake or sea, it gets polluted due to what? Because of the waste products. Okay, it gets polluted due to the waste products and present in the sewage effluents. But what happens that these conditions, the like the waste products, it doesn't remain so forever. Okay, because what? Because of what? Because the natural forces, because of the natural forces of purification, such as what? Dilution, sedimentation, oxidation, reduction in sunlight, etc., go on acting upon the pollution elements and bring back the water into its original condition. Okay, so that is just the way I am explaining that time, that what is a self purification process. So because of what is the why does it get automatically get purified? Because of what? Because of dilution, sedimentation, oxidation, reduction in sunlight, etc. So all these natural forces of purification, this goes in hand, and that's why the river or the sea or the lake, it gets purified by its own, and it gets back to its original condition after due course of time. Okay, so this automatic purification of polluted water in due course of time, it is known as what? It is known as your self-purification phenomenon. Okay, and if the self-purification is not achieved successfully, either due to too much of pollution, okay, discharged into it, or due to some other causes also, the river water itself will get polluted, okay, which in turn it may also pollute the sea where the river outfalls. Clear? So now, what are the various natural forces of purification? Just now we have studied like dilution and dispersion, sedimentation. So all this we will discuss it now. Okay. So the various forces of purification which will help in effecting self-purification process, those are like number one is your physical forces. Okay, so under your physical forces, now two processes are there. One is your physical process and the other one is your chemical forces. Oh, sorry, physical forces and chemical forces. So under your physical forces, three types of forces or natural forces are there. So number one is your dilution and dispersion. Okay, dilution and dispersion. Number two is your sedimentation. Number three is your sunlight acting through biochemical reactions. Okay, and number two is your chemical forces aided by biological forces, also called as your biochemical forces. And under that, number two processes are there. One is your oxidation, which is also a biochemical force. Okay, and number two is your reduction. Clear? So now we will discuss about the dilution and dispersion force. Okay, what does it mean? So you see, when the organic matter, or you can say when the putrescible organic matter is discharged into the river or lake or sea, okay, contained in the river stream, so what happens? It gets rapidly dispersed and diluted. Okay, it gets dispersed and diluted. So the action thus results in what? In diminishing the concentration of organic matter. Okay, this action of when the putrescible organic matter is discharged in a large volume of water contained in the river stream, so like it gets rapidly dispersed and diluted, and this results in diminishing the concentration of organic matter, and also it reduces the potential nuisance of the sewage. Okay, so there are certain parameters. Okay, there are certain parameters you see here. When sewage of concentration CS, okay, a CS concentration of sewage is taken, flows at a rate of QS into a river stream, okay, with concentration CR flowing at a rate of QR. The concentration C of the resulting mixture is given by, so like they are taking two things. One is your sewage and the other one is your river, okay, or river stream. So when the sewage is of concentration CS and the sewage is flowing at a rate of what? QS, okay, and they are flowing in what? In the river stream. So what is the concentration of the river stream? It is taken as your CR, and the the river is flowing at the rate of what? QR. Okay, so now we have to find the concentration C of the resulting mixture. So this is the formula for your, like, to find out the concentration of the resulting mixture. Okay, so this is the formula for your to find out the concentration of the resulting mixture. Okay, this one you have to remember. So now this equation, okay, this equation, it is applicable separately to concentrations of different impurities such as oxygen content, BOD, suspended sediments, and other characteristic contents of sewage. Okay, so now we will discuss about the sedimentation, like whatever natural forces we have studied, so we will discuss about that. So sedimentation, so what does it mean? So here the settleable solids, if present in the sewage effluent, will settle down into the bed of the river near the outfall of sewage, thus helping in the self-purification process. So here it is talking about the settleable solids. So those are present in the sewage effluent. So it will do, it will like settle down into the bed of the river, okay, near the outfall of the sewage, and thus it will help in what self purification process. Then comes your sunlight. So this one everybody knows, okay. So the sunlight, it has a bleaching and stabilizing effect of bacteria, okay. So it removes, that means it is a good thing, okay. So the sunlight, it has a stabilizing effect to kill the bacteria or effect of bacteria. So it helps certain microorganisms to derive energy from it, okay, and also they convert themselves into food or other forms of life, and that one we know, it is simply known as what, photosynthesis. Okay, so the like the evolution of oxygen in river water due to sunlight, which will help in achieving what, self purification through oxidation. Okay, so photosynthesis due to sunlight, it also helps in like achieving the self purification of river stream through oxidation. So now oxidation we will discuss. So the oxidation, you see, the oxidation of the organic matter present in sewage effluent, it will start as soon as the sewage outfalls into the river water containing dissolved oxygen. Okay, so the deficiency of oxygen so created will be filled up by the atmospheric oxygen. So the process of oxidation, it will continue till the organic matter has been completely oxidized. This is the most important action responsible for affecting self purification of rivers. So here what is said is that the oxidation, okay, the oxidation of the organic matter that is present in the sewage effluent, it will start as soon as what happens, the sewage outfalls, or the sewage will fall into the river water, okay, that contains what, that contains dissolved oxygen. So there will be some deficiency of oxygen in the river stream, and that will be like filled up by the atmospheric oxygen, okay. So that this the process of oxidation, it will continue, okay, it will continue till the organic matter, it has been completely oxidized. Okay, so this is an important important factor also, you can say important action also, you can say responsible for what, affecting the self purification of rivers. Clear? Then number last is your reduction. Okay, one is your oxidation, the other one is your reduction. So reduction, why it occurs? It occurs due to the hydrolysis of organic matter settled at the bottom. Okay, either chemically or biologically. So like the anaerobic bacteria, those bacteria which survive without the oxygen. So those bacteria, it will help in splitting the complex organic constituents of sewage into liquids and gases. Okay, so this is a reduction process. And also beyond this all these factors, so there are some other factors on which this natural forces of purification depends upon. So those are, number one is your temperature, number two is your turbulence, number three is your hydrography, such as the velocity and, just a second. Okay. So, like the other factors which also depends upon the natural forces of purification. So those are what, like temperature, turbulence, hydrography, and available dissolved oxygen, and also the rate of re-aeration. So these are also the some of the other factors. Those are depend upon your self purification process. Okay. So we will quickly solve for numerical. Okay. So this is based on your, just now we have like discussed about the concentration part. So you see the question, the sewage of a town is to be discharged into a river stream. Okay. The quantity of sewage produced per day is 8 million liters and its BOD is 250 milligram per liter. So if the sewage in the river is 200 liter per second and if its BOD is 6 milligram per liter, find the BOD of the diluted water. So first of all, the you have to see the sewage discharge. Okay, the sewage rate of sewage discharge, you can say what it is. The concentration of sewage is given as to be 8 million liters. Okay, 8 million liters. So first you convert the 8 million liters into liter per second. Okay, so okay, so the meeting will end in 5 minutes. So after that, if it disconnects, so you join it again. Okay. So, like the sewage concentration, it is given as your 8 million liter per day. So, your first you need to convert it to liter per second. For that it is like you have to multiply by 10 to the power 6 and then divided by your what, 24 into 60 into 60. Okay, so you will get the sewage concentration, that is your QS. Okay, now you what it is given, it is discharged into a river rate of river discharge of the river is also given as your 200. You see, this is 200 liter per second. Then what is the BOD of the sewage? BOD of the sewage is given as to be 250. You see, and its BOD is 250. So the BOD of the sewage is given as to be 250, which is your CS. Okay. Now what is CR? BOD of the river. It is your given as to be 6 milligram per liter. Okay, so now every value you got, so you now just put it in the like formula. Okay, just now you got the formula, CS into QS plus CR into QR divided by QS plus QR. Okay, so every formula, every value you have now, you just have to put it in the formula and you will get the BOD of the diluted mixture as 83.21 milligram per liter. Okay, this is a very simple numerical. Just you need to know what, which is the like discharge rate, or which is the your BOD of the sewage and river on the sewage. So everything, if you know the all the values, you can find it easily. Okay, so next numerical is a very short one, like not short one, it's actually a continuation of the for this numerical only. So like it is given here in the above example, what should be the river discharge if it is desired to reduce the BOD of the diluted water to 20 milligram per liter. So they are asking what should be the river discharge, the discharge of the river. Okay, if it is like you have to reduce the BOD of the diluted water to 20 milligram per liter. So here the mixture, the BOD of the diluted mixture is given. Okay, so your C, capital C is given to be 20 milligram per liter. Now you need to find out what? You need to find out QR. Okay, what is QR? QR is your discharge of the river. So you need to find out QR. You use the same formula. Okay, you use the same formula and just you put in place of C, you put 20 milligram per liter, and other values are already given in this question itself. So after that, after solving, you will get QR is equal to 1521 liter per second. Okay, so these numericals are very simple. Okay, so so you try to solve it out. Okay, so I will take the attendance. Just wait. Okay. So okay, so for today we will end it up to for up to this much only. Okay, so we have to, you know, like the you have got the message, you know, like we have the class till 20 January, so we have to go a little bit slow, otherwise we will like it will end up quickly. Okay, so we have to go a little bit of slowly. So for today we will do up to here itself. Okay, so next class on Wednesday we will be going to the other topic. Okay. Okay, so let me take the attendance. Okay, I think this will end. So can you people rejoin again? Can you people again rejoin? I think this will end. Only 3 minutes are left.
Yes, ma'am.
Okay,
Yes, ma'am. Yes, ma'am.
you leave and then you can rejoin. Okay, to the same link.